Hey guys, we're going to talk about intermolecular and intramolecular bonds. On your intramolecular bond, that is how are they involved, how are they bonded to each other. Remember that your covalent bonds are sharing the electrons. Ionic bond is transferring electrons. And the metallic is your electron C model. So that is how the compound is bonding within itself. Intermolecular bonds is how are they attracted to each other. With everything, it is always about the electrons, and what's involved up here is electrons. But what's involved is how are the electrons on one compound interacting with another compound. With your dispersion forces, I'm going to kind of draw it up here. What you have is, we talked about fluorine with your non-polar covalent bonds, is the electrons manage to kind of sync themselves up so that occasionally you have a negative side and occasionally a positive side, and that's how it'll attract itself to other molecules ever so briefly. This is also called London dispersion forces, van der Waals. There are different names that it goes by, but they end up just kind of coming close to each other. It usually has your gases. Your gases don't really come close to each other, right? So those are the types of interactions that you have. With dipole-dipole, you have going through oxygen-fluorine that we talked about. Remember that fluorine has like a stronger hold on it. Well, it's going to kind of be attracted to the fluorine-oxygen will have a brief attraction to each other, because this is kind of a positive side and that's a negative side, because the fluorine is pulling everything to it, or most of it. Oxygen ends up kind of positive, not completely positive. And so we use this symbol to say partially positive, partially negative. Dipole-dipole is the same exact thing, except you have to have hydrogen, obviously, and it's going to be bonded to one of three elements: your fluorine, oxygen, or nitrogen. When hydrogen is bonded to a fluorine, oxygen, or nitrogen, it ends up having a really strong attraction, because when we look at water molecules, one that you're used to, water's H2O, it has a strong attraction. The hydrogens will have a strong attraction to the oxygen, the electrons on that oxygen, forming a really strong interactive bond between the two things. This is why water has the properties that it does, is because of this strong interaction. Dipole-dipole with hydrogen bonding is the strongest of the three types of intermolecular forces. When we talk about Lewis structures, we're going to actually look at what kind of bonding do I have going on between the different molecules once we figure out how are those molecules drawn. See you in class.